Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in 8051 microcontroller. We're going to see branching instructions of 8051. We already started the instruction set of 8051 microcontroller. We have posted 2 to 3 videos so far: arithmetic instruction, logical instructions, and we have also seen data transfer instructions, and today we're going to see about branching instructions of 8051. Right, this is very important concept in 8051. Right, before seeing the branching instructions, I'll just explain. You have only two branching instructions, that is jump and as well as call instruction. And first I'll explain what is jump instruction and what is call instruction, so that you can clearly understand whenever we see the instructions. Right, so first you got to understand the difference between jump and as well as call instructions. My dear students, you would have executed a lot of programs in your lab classes using 8051 microcontroller, right? So whenever you want to jump any particular instruction, that is, you would have given a label like here, over, something like that, right? Whenever you give that instruction, you would have come across this jump instruction, right? So what jump instruction will do, it will make the program counter, right? It will change the program counter permanently, right? That is, you can see here, it will be executing the instruction one by one, sequentially it will executing the instruction, right? And say for example, if there is jump instruction here, what it will do is it will jump from this place to here, from this address location to this address location, which means the program counter value will be changed permanently. Why I say permanently? Because after reaching here, it will start executing the instruction one by one here, right? So once again, if it has to reach this particular instruction, this particular location, then we have to provide another jump instruction to come here, right? So jump instruction as if now, which is nothing but the instruction which changes the value of program counter permanently, right? That is jump instruction. So what is call instruction? In last video I have explained what is interrupt, right? So whenever there is a particular program executing, there will be interrupt, and when the interrupt has happened, right, the microcontroller will go to the interrupt location, it will execute some instruction, and after executing the instruction, it will come back to this original instruction, right? Now this particular instruction is called a subroutine, right? So here what happens, we will use call instruction, right? So that is, it will go to this subroutine and it will come back to this subroutine. It will come back to this main program, right? So here what happens in call instruction, the program counter value is temporarily changed, and once again after completing this subroutine, it will go to this main program. Remember I explained about push and pop instruction. Push, it will add the value to the stack pointer, and pop, it will remove the value from the stack pointer, right? So after removing from the stack pointer, it will execute the main program normally, right? So that is for a temporary change, there will be a change in the program counter, right? That is about call instruction, right? And you have something called absolute jump and absolute call, which is nothing but we have already seen in addressing mode. What is absolute addressing? What is long addressing? Absolute addressing is a 2-byte address, right? Whenever you use for a short call or within the memory, right, we use absolute call. And for long call, what we will do is whenever we have to access the external memory, we can use the complete external address, right, external memory. That is about the jump and as well as call instruction. With this basic, if you understand, if you look at the instructions, the operations, you can definitely understand what it performs. Okay, right. Now when it comes to jump instruction, whatever I said, that is given here, right? And when it comes to jump instruction, right, you have two different types of jump instruction. One is jump unconditionally, and one is jump with conditions, right? And when there is jump with condition, it can be jump with byte condition or jump with bit condition. As simple as that. That is, jump with condition is nothing but it will jump only if the condition is satisfied. That is, if the carry flag is 0, then jump. If the instruction is jump if carry JC, then if the carry flag is set, right, then it will jump, right? And say for example, if we say that carry flag is 0, then jump, then if the carry flag is 0, it will jump. That is, if the condition is satisfied, it will jump, right? And this condition can vary. Say for example, it can compare 2 bytes, right? And we can say that jump if equal, that is compare jump equal, that is it will compare, and if it is equal, it will jump. If not, it will not jump, right? This is called as jump with condition. Jump unconditionally is normally which we use in program, that is there is no condition, right? Even conditions we use in programs, but jump unconditionally is without any particular condition, right? It will just jump to your particular location, that is jump unconditionally, right? And call a subroutine. I have explained what is call a subroutine, right? Whenever there is an interrupt, it will go to a different location, it will execute those instructions and come back, right? And while coming back, you need one particular instruction, that is return instruction, RET, while from subroutine to the main program, right? So we will see all these things here, right? So, and when it comes to jump instruction, you have to understand what is absolute addressing, what is relative addressing. I have already said what is relative addressing. Relative addressing is jump, right? That is, by using the offset value, it will jump to the location. Say for example, if your address byte is 0002, right? And what it will do is, if you have an offset value of 4, right? What it will do is, the program counter will increment a value, right, which is 00003, and from here it will add +4 and it will go to the address 0007. You remember the relative addressing, right? So we will use relative addressing or absolute addressing here. And when we use relative addressing, we will use 127 bytes to minus 128 bytes, right? And I've already explained what is conditional jump and what is unconditional jump, right? And you can see here, we will start with very simple jump instructions, the bit jumps instructions, right? What is bit jump instruction? Bit jump instruction based upon a particular bit, right? The jump will take place to an address based upon the particular bit. Say for example, you can see here JC, this nothing but RADD is nothing but relative address, right? What is JC? Is nothing but jump if the carry flag is set to 1, right? JC is nothing but if the carry flag is set to 1, jump to this particular address, right? This is about the bit conditional. Based upon the carry flag, you take the decision, right? What is JNC? It will jump to this relative address if carry flag is 0. That is, you can see jump, no carry. JNC is nothing but jump, no carry, right? So that is, if the carry flag is clear to 0, then it will jump. Similarly, JBB, which means jump to this relative address if this bit is set. The bit is set. That is, if B is set to 1. Similarly, J and B is nothing but if the bit is not set, it will jump to this particular location, right? And you have to understand one particular thing here. This particular instruction, this is peculiar instruction JBC, which performs two things. That is, it will jump to this relative address, right? If this bit is set to 1, if the bit is set to 1, it will jump to the relative address, and also what it will do is, before jumping, it will clear this bit to 0, right? You can see here, jump to the relative address, right? Which if the bit is set to 1, and before jumping, what it will do is, or after jumping, it will clear that bit, right? It will clear that bit. This will just jump, right? If the bit is set here, if the bit is set, it will jump, and also it will clear that bit, right? So this is very simple bit jumps, right? And now you can see, you don't want to get confused with all this informations. Very simple. Just listen the instructions, right? This is compare and jump. This is also a conditional jumps, right? But here what happens here is, it will perform two different operations. That is, it will compare and will check whether it is equal or not equal, right? And it will jump based upon the conditions given, right? And for all this compare instruction, one thing you have to understand, whenever the destination byte is lesser than 1, lesser than the source byte. If the destination byte is lesser than the source byte, the carry flag will be set, right? It will change the carry flag to 1, right? It not only perform the compare and jump, it also do this particular operation. That is why I said it performs 3 operations: compare and then jump and then change the carry flag. Right now, with this basic, see this particular instruction, right? You can see here CJNE, right? Which is nothing but, you can see this is relative address, this is the direct address given, right? Now because the given instruction is, right, compare jump if not equal, compare jump if not equal, that is CJNE, compare jump if not equal. That is, we have to compare the accumulator and the given address and jump to the relative address if they are not equal. If this is not equal, then we have to jump to this particular address, and predominantly you have to do one particular thing. This is the destination and this is the source. If A is lesser than this particular source, then the carry flag has to be set to 1. I repeat this again. CJNE is nothing but compare and jump if not equal. That is the instruction. So this is the relative address where we have to jump, right? This is the accumulator and this is the address, right? So here what we have to do is, it will just compare A and address, right? And it will jump to this particular address if it is not equal. You can see here, compare the content of A with the content of direct address, and if they are not equal, jump. Provided, what it will do is, it will also set the carry flag if A is less than the content of the direct address, right? Now I'll explain this one. Now again, compare and jump if not equal, right? So we have to compare this and this number given. If they are not equal, we have to jump to this particular address, right? Provided we have also set the carry flag. If A is lesser than the given number, then carry flag will be set, right? You can see here the content of A, right? It will compare the content of A with the given number, and if it is not equal, it will jump and the carry flag will be set, right? If A is less than 1, otherwise it will be 0, right? The same condition here. You can see here it is not accumulator, but it is given as the register, the content, and as well as the immediate, right? It will compare and it will jump to not equal, and it will set the carry flag if this value is lesser than the given value. The same thing is here, right? Now you understand, right? And you can see this is another thing where you can see D jump if not 0, right? That is, what it will do is, it decrement and jump if not 0. That is, whatever given, right, we have to given this particular, it will jump to this particular relative address. This RIDD is nothing but a relative address. It will jump to the address, right? That is, when it will jump, right, first what it will do is, it will decrement the register, right, and decrement the register, and if it is not 0, after decrementing, if the register value is not 0, it will jump. If not, it will not jump. You can see here, decrement the register by 1, jump to the relative address if the result is not 0. Similarly here, right, jump if not 0, decrement, jump if not 0, this value is given. We have to decrement this address, right, and if it is not 0, it will jump to this particular relative address, right? And the next important jump instruction is JZ relative address. That is, jump if 0 to this relative address, right? That is, it will jump to this relative address if A is equal to 0, right? So you can see here, jump to this relative address of A is 0, and it will not do any changes to any flags or A register. What it will do is, if A is equal to 0, it will jump. And this just opposite of this one, that is JNZ relative address. That is, jump no 0, right? It will jump to this relative address if A is not equal to 0, right? So this is about the conditional jumps instruction, right? So far what we have seen is, we have seen conditional jumps, about bit jump and as well as byte jump, right? And now we will see about unconditional jump. Unconditional jump is, you don't want to worry about any conditions. It will just jump to the given address or given location, right? That is why it is called as unconditional jumps. You can see here it will jump to this address, right? Here in this particular instruction we have to calculate the address, right? So that is, this instruction will jump to the address, but the address is calculated by adding the accumulator value and the DPTR value. So jumping to this address, you can see here, jump to the 16-bit address formed by adding A and DPTR. Similarly, A jump, that is absolute jump, right? I have already explained about absolute addressing and as well as long addressing, right? Where we use absolute addressing, where we use long addressing. Whenever we use the external memory as well, the complete memory, we have to use long addressing. And whenever we use within the RAM, right, within the program memory, then we use this absolute addressing, which is 2-byte addressing, right? So here you can see it's absolute jump, which is the short address, that is, it will do a short jump to the given address. And similarly, L jump is nothing but long jump to this given long address, right? And SJMP, once again, short jump to this relative address. Here there is no condition, and that is why it is called as unconditional jump. It will directly jump to the given address, right? NOP is nothing but no operation. It will not do any particular operation. That is why it is called NOP. Do nothing and go to the next opcode. That is, it will not do any operation. That is NOP, right? So this is about jump instruction, right? And the last instruction is call instruction in 8051. I have already explained what is the difference between jump and call when we use call instruction, right? And call instruction mainly used when we go for subroutine, right? And once again, if it is we are going to use absolute addressing, that is going to be a short address, that is, if it is within the memory, right? And similarly, the long addressing, if you want to go for the complete address, that is for the complete memory, external memory also, then it is called as long call, right? But what is the exact operation? You want to understand once again the subroutine, how it works. That is, the main program will be executed, right? Until an interrupt comes, what will happen? The interrupt will have a memory location, say 0F, something like that, right? Now the microcontroller will stop the main program and it will go to the subroutine program, right? It will execute that subroutine program, and at the end of the subroutine program, right, it will come back to the original program, right? For coming back to the original program, we will use an instruction which is called as RET. It is called as RET, return instruction. Like the subroutine program will be executed until it reaches this instruction. Once it reaches this RET, it will go to this particular main instruction, right? And I already explained what is push and pop operation, how the microcontroller jumps from this particular main program to the subroutine program, and from subroutine program to the main program, right? That is by using push and as well as pop instruction. That is, push instruction will increase the stack pointer. It will add the address of the next instruction which is going to be executed. And pop instruction, what it will do is it will remove that instruction which is already added, and it will be saved in the program counter, so that it will execute the main instruction one by one, right? And you got to understand what is the difference between RET and RET1, RETI, right? This is just return program, that is, it will return to the main program. And RETI is nothing but it will return to the main program, and also it will reset the interrupt, right? Why is that resetting the interrupt? I already explained that main program is executing. If some interrupt happens, right? Say for example, you have an external interrupt, EXT0, that is equal to 1. If this becomes 1, the interrupt will happen. And once if the interrupt happens, it will go to the subroutine, right? It will do all the subroutine instruction, and then if you have RET, what will happen is it will come back to the main program, right? When it come back to the main program, it will start executing it, but once again you can see the external timer is already 1, right? So what will happen is again an interrupt will be created. To avoid that, what we can do is we can use RETI. RETI, what it will do is it will not only go back to the main instruction, it will also reset this interrupt, right? And you can see here that is what given, right? I'll just explain this again. A call short address nothing but call the subroutine. Call, it will make a call to the that given address, that is it will go to that particular address. Similarly, long call address, it will go to that particular subroutine, that is long address, right? The subroutine which is given with the long address. And return is nothing but it will return anywhere to the program address, right? And similarly, RETI, as I said, it not only return but also reset the hardware timer, right? And that is why it is called as RETI, right? So this jump and call instruction is very, very important instructions in 8051, right? And you can see that whenever we use call instruction, we use push and pop, right? Push instruction, and you can see this is pop instruction, right? Where you can see RET1. That is by using push operation, right? You will push the information to the stack pointer, and by using pop operation, you will remove that instruction from the stack pointer, right? And this is the summary of the jump instruction. We have seen conditional jump and unconditional jump, and all these instructions you can see this particular instruction will be using direct addressing. Most of the jump instruction use accumulators only, right? And you can see this instruction uses indirect and register addressing, right? And all this jump instruction needs 2 microseconds of execution time, right? And similarly, the unconditional jumps mostly needs 2 execution time. And similarly, call instructions also needs almost the same execution times. Okay, so today what we have seen is we have seen the very important instruction set of 8051. We have seen the jump and call instruction, which is the branching instruction. I've explained what is the difference between jump and call instruction, right? And when the jump will happen, what is conditional jump, what is unconditional jump. All this is very important topics, right? I believe this video will be very useful for you, my dear students. Thank you very much.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.